Hi, this is Changster. Welcome to my video on operation in scientific notation. Today we're going to learn about multiplying and dividing in scientific notation. So if you can remember what is scientific notation, that will be helpful here. And we're going to do a quick recap on what is scientific notation before we begin. Okay, so a number is in scientific notation when it is, scientific notation, when it is in the form of, is written as a product of a times 10 to the exponent of n, and a, which what we call the coefficient, has to be greater than or equals to 1 and less than 10, and n, the exponent for the 10, would have to be an integer. Okay, so we're going to look at the first example, which is going to be on multiplying numbers in scientific notation. So let's look at the first example. We have 1.5 times 10 to the third. Okay, this number multiplied by another number, 8 times 10 to the second power. Okay, so if before we look at how we can simplify this number in scientific notation, I'm going to look at how it looks like in standard form. So I'm going to just convert these two numbers in standard form. If you remember how to convert these two numbers, so when you have 10 to the third power, what do? You actually move the decimal point to the right by 3 times. The number becomes bigger, 1 2 3, so you have 1500 here. Okay, times, and we have 10 to the second power, so you have 8, which you put the decimal point and you move the decimal point 2 times, 800. So from here you can see, if we multiply this out, you get, so 1500 times 800. So we will multiply that out, so, and 0 times 8 would be 0, 0 times 8 is 0, 5 times 8 would be 40, and 1 times 8, you end up with, 8 plus 4 is 12. So this number, if you convert this to scientific notation form, we know that we have to put a decimal point after the non-zero leading digit, which is 1, and you will have to, so you get 1.2 times 10. Okay, and you can see the decimal point will have to move to the right, 1 2 3 4 5 6. So 1.2 times 10 raised to the 6th power. So this is how you go from standard form to scientific notation form, right? Okay, so let's look at how we can simplify this product using what we know about scientific notation. So from here you can see that I can rearrange this number as 1.5 times 8 times 10 to the third times 10 squared. Okay, this is the reason why we can rearrange numbers because of the commutative property of multiplication. And from here we can now group the two numbers. So 1.5 times 8, so 1 and 10 to the third power times 10 squared. So this, we are applying the associative property of multiplication to simplify this expression. And 1.5 times 8, if you work it out, 1.5 times 8, so you end up with 12. Okay, so it's equals to 12 times, and for these two numbers, for the product, we can apply the product of powers property, which is to multiply powers of the same base, all you have to do is to add the exponent. So you get 3 plus 2, and then you end up with 12 times 10 raised to the 5th power. Now you gotta look out for the coefficient, is this greater than or equals to 1 and less than 10? In this case, we can tell that it is not. So you will have to put a decimal point after 1. So you end up with 1.2. As 12 is decreased by 1 decimal place, then you have to multiply it by 10 raised to the 1 power to increase it by 1 decimal place. And you will bring down the original 10 to the 5th. So from here, you can see that you get 1.2 times 10, all right, to the first, and times 10 to the 5th. And you will have to apply the product of powers property to, and in that case, you have to add up both powers. So you end up with 10 to the power of 6. So this is the answer for this example. One very useful observation you can see here is that as you see that 12 is decreased by 1 decimal place to 1.2, you can see that your 10 to the 5th is now increased by 1 number to 10 to the 6th. So something you can see as the coefficient decreases by 1 decimal place, the power actually increases by 1. Next, we're going to look at another example, which is to divide numbers in scientific notation. So example 2, we have, say, 3 times 10 to the 3rd power divided by 6 times 10 to the 5th power. So before we look at how it works in scientific notation, let's look at it in standard form. So if we have 3 times 10 to the 3rd power is actually, if you put a decimal point after 3, and then you're going to have 3 zeros, so it becomes 3,000 divided by 6 will be, there will be 600,000. So if you want to simplify this fraction, so you can see that I can divide both the numerator and denominator by 1,000. So I end up with 3 over 600, and also 3 and 6 are both divisible by 3, so I end up with 1 and 2 in the denominator, so that's 1 over 200. And to write this in the decimal form, I will express it as 1,000 in the denominator, so I have to multiply both the denominator and numerator by 5, so I get 5 over 1,000, and that will give me, so again, you move the decimal point to the left if dividing by 1,000, so 0.005. To write 5,000s in scientific notation, we have to make sure that the first digit is 5. And when you make the number in decimal form bigger by 3 decimal places, the exponent of 10 has to decrease by 30 decimal places. So something for you to think about is that when the number in index form is bigger, then the exponent of 10 has to be smaller. We will now look at how we can simplify the two numbers by using the rules of exponents. So I'm going to first break it up to 3 over 6 times 10 to the 3rd divided by 10 to the 5th. This is using fraction rules where you can just break up the fraction into the product of two different fractions. And we know that 3 divided by 6 will give us 0.5. And 10 to the 3rd divided by 10 to the 5th power, we can use the quotient of powers property. And to divide powers with the same base, we will have to subtract the exponent. So it's 10 to the 3rd minus 5. So you end up with 0.5 times 10 to the power of negative 2. And you can see over here that 0.5 is not the coefficient that we want for scientific notation. So you have to rewrite this as 5. And 5 times 10, okay, to a power. So we don't know what it is. So when you increase 0.5 by 1 decimal place to get 5, the power of 10 has to decrease by 1. So that's why you got 10 to the power of negative 1. And we will bring this power down 10 to the power of negative 2. And again, we will have to combine these two using the product of powers property. So you end up with 5 times 10 to the power of negative 1 minus 2, you get negative 3. So you could see from here that you have the same answer for both, but on the one on the right, we're using the rules of exponents, and it's actually a lot faster if you can apply them efficiently. Now we're going to talk about the rules for multiplying and dividing numbers in scientific notation. So for multiplying, let's look at a times 10 to the n times b times 10 to the n. So for this case, you can use the commutative property of multiplication to rewrite the two coefficients as a times b. And you can combine the two tens power by adding the exponents. This is for multiplying. For dividing, I'm going to write a times 10 to the n divided by b times 10 to the n. And using the product of fractions, I can break up the fraction as a divided by b times 10 to the power of m minus n. This is using the quotient of powers property. And before you want to simplify this, you got to make sure that your two product, your a and b, all right, which is the coefficient of your answer, and a divided by b, the coefficient of your answer. So the final coefficient has to be greater than or equals to 1 and less than 10. And to find out how we can convert the two numbers into scientific notation, please refer to my previous examples or my video on writing in scientific notation. All right, thank you and goodbye.